All right, everybody, welcome back. It is Thursday, 11 a.m. Eastern, and it is time to talk Kubernetes. My name is Marco. I'm the Nginx evangelist at F5, and I will be learning Kubernetes alongside everybody else, like I've mentioned in the previous two episodes. I have some experience with containerization. Ooh, that was a word. Have some experience with containerization, but not a lot of experience with Kubernetes. So I'm learning along the way with everybody else. In the previous episodes, we took a look at what my plan is, Kubestronaut, the 5 certs that get you that coveted blue jacket, and what the main focus area for learning will be. So I want to make sure that I can help you along the way as I learn, and any lessons that I learn are also applicable to your learning, and I want us all to succeed in this endeavor. Now, today is going to be a little bit of a different episode. I'm not going to talk about exams. I'm not going to talk about exam questions, even though I've built that exam prep tool that I'm still iterating on. Obviously, it's version 0.02, so very, very low. But I do have a couple individuals who have shown interest to test it out, and yeah, I'm looking for people to adopt and contribute to that tool. I want to make a learning tool that can be applicable to anybody, and if you don't like how it looks, how it feels, how it works, you're welcome to fork it and use it for your own purposes in your own learning journey, or however you want to use that platform as well. There's all options are on the table. So I named this session "The End of the VM," episode 3, "The End of the VM." Why am I talking about the end of the VM? What are virtual machines? What do they have to do with Kubernetes? What am I talking about, really? Well, I have just spent 3 days at conferences. I was in Atlanta at Red Hat Summit, and I was also attended a Kubernetes community days in Toronto, and I talked to probably, well, I'm going to say over 100 people, but it's probably more. It's probably more than just over 100. And with that, I have some lessons from the field, some anecdotes from the field that I want to share with everybody. And I think that we're at a very important inflection point where there's going to be a massive change happening in what we consider as the core enterprise architecture for lots and lots of businesses. And let's dive deep into it. First, let's talk about virtual machines. First, let's talk about what virtual machines are and how they matter. There we go. All right. Let me put myself to the side so you can actually see all of this screen that I'm sharing here. So, in general, if we look at the big picture of Kubernetes, pods, and containers, and virtual machines, they're very similar. They're very similar. What we have is, in Kubernetes, we have a pod. We can have one or more containers in a pod. Just like in a virtual machine, we can have one or more applications. We essentially are isolating those applications, those containers, from the underlying physical hardware. So the goal of the virtual machine and the goal of the pod is to isolate that application, make it entirely independent from the underlying architecture. Which means, in an ideal world, I can take that pod, or I can take that virtual machine, and I can ship it anywhere. I can drop it onto my desktop. I can test it out on my laptop. I can run it on a server in my data center. I can ship it to the cloud, and it's going to run without any modification. And this is, to a certain degree, true, especially about containers, because they're very interoperable. Now, is this true about virtual machines? Yes and no. Why do I say yes and no? Well, a virtual machine is a virtual machine, right? It's just a virtual hardware. We've got an operating system inside of that virtual hardware. It's got all its binaries, libraries. And mind you, these operating systems can be quite different. This could be Linux. This could be Windows. This could be a Mac OS, Mac server, whatever you want to run on these three different types of virtual machines. Whereas with containers, we have a little bit of less choice of the operating system itself. So we have to have a kernel in the host operating system that supports either the application, or if this is a really heavyweight container that contains a different operating system running on the same kernel, we can support that. So let's say I'm running some kind of operating system underneath, some kind of Linux with kernel version XYZ. Now, if I want to run a different distribution of operating system inside of a container, I can, as long as it supports the XYZ kernel. Is that important? Well, that is important to differentiate between especially capabilities of containerized platforms and capabilities of virtual machine platforms. So I have variety, I have choice. Now, is variety and is choice something that's good? A lot of times we see that when we have a certain unified environment, when we have hundreds, thousands, tens of thousands, or even more systems, what enterprises tend to do is they tend to unify on a certain operating system, on a certain platform. So what's going to happen in hypervisors is a lot of the times this guest operating system, nowadays, probably 90% of what enterprises run is going to be Linux. It's going to be a certain Linux at a certain kernel. It's typically even a certain distribution from a certain vendor that offers support to that company. So it's going to be, Ubuntu or Kubernetes, or sorry, not Kubernetes, or Red Hat, or some other type of Linux operating system that actually has support attached to it. So what you're going to see is that rather than seeing a lot of diversity in the guest operating systems on a specific hypervisor, you're going to actually see that there are pretty much the same machines running on top of that operating system. Guest operating systems, they're all roughly the same. So we've got a lot of duplication here. A lot of duplication happens. Okay, so if we have the same applications and roughly the same operating systems, then what is the major difference between your containers and your virtualization platforms? Well, it's the control plane. The hypervisor lets VMs be run on top of that specific hypervisors. Whereas with Kubernetes, the control plane allows us to run the pods. Now, here is where the big difference with cross-environment support comes from. Kubernetes is designed as a cloud-native platform. It's ran by the Cloud Native Computing Foundation. And the purpose of Kubernetes is it has to be agnostic on what it runs on. Completely agnostic about hardware, agnostic about what kind of platform there is, and no vendor lock-in essentially to the underlying component. So you're on Kubernetes, again, on your laptop, on your server, or on the cloud, it's the same pods. Very, very interoperable. Now, what happens with the virtual machines is you get locked into the hypervisor. You can't just drop virtual machines from VMware or from Hyper-V or from KVM or from Zen or whatever hypervisor you're running. You can't just run those on another hypervisor. Interoperability between hypervisors is severely limited. Severely limited interoperability. There are some unified standards for unified virtual machines, but really nobody uses that. If you're running VMware, you're going to be running VMDKs, you're going to be running a VMware machine configurations. If you're running Hyper-V, you're going to be running VDKs, configurations for Hyper-V. There is no interoperability between hypervisors. And this is where the big move from virtual machines to the cloud is actually going to happen. Now, why am I saying this? Like I said, I spent 3 days at conferences talking to dozens, over 100 people probably. And while there was talk of AI, there was a lot of talk of AI, the biggest conversation was we want to move off of our virtualization platform. We want to have virtual machines that actually do what was promised about virtual machines. Things like cloud bursting, we want to run them at the edge, we want to run them inside of our data center, we want to run them anywhere we can in the platform itself. That doesn't matter what the platform is, doesn't matter where we're running. And this is the thing that the virtual machine, and especially the hypervisors that are ran by different vendors, companies, this is where there's sort of a disconnect between what the customers want and what the hypervisor actually offers. I'm not saying that there isn't a capability that allows you to move your virtual machines to the cloud. There definitely is. The capability exists. Depending on the vendor, there's going to be different support in different cloud providers, but it gets super complicated. It gets super complicated or requires a special license, and that license can be very expensive. And this is where customers are finding that right now having virtual machines is more of a burden than a benefit. Having virtual machines is not really turning out to be that promise of flexibility, the promise of scalability, the promise of quick spin-ups and things like that. Whereas on the other hand, containers spin up in seconds. They're super lightweight. They're super portable to any platform, to any cloud, to any physical box that has a processor and some memory, essentially, and perhaps even some storage if need be. We can obviously cut out the overhead of the guest operating system. How much memory or CPU do we need to run our application? At the smaller scale, the applications need megabytes, a few cycles on a CPU, whereas the guest operating system, just to spin up the guest operating system, you're using gigabytes of memory. You're using 1 or 2 CPUs for the operating system to actually keep itself alive and do all the things that an operating system needs to do. So what we're getting is we're getting much higher density because we're cutting out all of these duplications of operating systems that are running across the board. Now, there are hypervisors with memory optimizations where if you're running one operating system and you're duplicating it 10 times, there is some shared memory pool in there. You can turn that feature on or off. So again, perhaps for security, you want to have your machines entirely isolated from other machines. You don't want to share anything. Each VM is more secure technically. I would beg to differ that there is security, and I'm going to get into security in a second. But for now, containers, they spin up fast. They're super high density. They're super portable across environments. They can be really efficient, like super efficient, better at resource utilization, better at spinning up, scaling out, scaling in. All happens in seconds. Whereas with virtual machines, minutes, maybe tens of seconds if you have super highly optimized Linux operating systems that can actually boot up in tens of seconds. I know one of my machines that I optimized specifically for one task, I can get it to boot up in about 18 seconds from powering on a machine to actually getting a command line in Linux, but it doesn't load really anything. Everything else is loaded after. So really, all the applications on that machine are ready within minutes. Yes, the operating system takes 80 seconds to boot, but the containers, the applications, they spin up afterwards. So we're looking at minutes for startup for virtual machines. And if you have an application where there's very spiky traffic, it's very difficult to predict that traffic. It's very difficult to satisfy that traffic with virtual machines. So what is the real benefit of the virtual machine? Well, technically, this is where the difference starts, right? Pods, you can think of them as virtual machines. Containers, you can think of them as apps inside of those virtual machines. The difference starts at where we're kind of like here in the green. It's the host operating system or a bare metal operating system for that hypervisor itself. Host operating system, we're going to need Linux, we're going to need Windows to run those containers. And we know that securing an operating system, giving it access to, giving a user or an admin or somebody who has access to the operating system, we're technically allowing them to see all of these pods. We're technically allowing them to see the whole cluster space. So the real attack vector for containerization of any kind would be getting onto one of those host operating systems and being able to see a lot of containers, a lot of applications. We're going to hear from everybody who's confident about hypervisors being more secure say, well, yeah, the vector of attack for a bare metal hypervisor that I can typically also get into. I can either SSH into it or get into it via some kind of API process. The bare metal hypervisor, the common belief is, oh, you know what? It's more secure because there's just not many known attack vectors. And this is the message that I heard from, well, dozens of people. At least a dozen people said, well, yeah, but the hypervisor is so secure that nobody knows how to exploit it. But then when nobody knows how to exploit it, the bare metal hypervisor, nobody even knows how to protect it either. So a lot of times, these bare metal hypervisors don't have any kind of security tools on them. A lot of times it's because there's no security tools that fit onto them. And other times it's because the sort of perception of hypervisors as being super safe is probably a little overconfident. Not protecting an attack vector because it's deemed to be, oh, you know, this is safe as houses. that is not a good approach. So these anecdotes that I'm hearing from individuals saying, oh, yeah, we prefer the hypervisor because it's more secure than the operating system that runs containerization. That could be a little bit of a security by obscurity fallacy here, because you can protect your operating system, and there are known ways to audit, protect, detect, prevent any kind of shenanigans going on in your operating systems. Whereas on the other hand, there are very few ways. I mean, it can be kind of difficult to actually have the bare metal operating system built up from a security standpoint to the point that you can build up your host operating system. So to that respect, it's actually easier, and you can probably achieve a better compliance posture with a traditional standard operating system than you can in some situations with a bare metal hypervisor. And yeah, at the end of the day, we still have the physical server, we have the infrastructure, and here it's physical access. Just not letting people grab your servers and take them out of there. So what is the future for virtual machines? Why are we still using virtual machines? Well, they're still good. They still do things. There still are situations where we want to pack different things together. We want the monolith because of the capability of the monolith. Let's say I've got a big video I'm sharing. I'm sharing a big video. I'm ingesting it here with Pod C. Pod C inspects the video, and it's tens of gigabytes. Pod C inspects the video and then passes it over to container A in Pod 1 here, which then passes it over to D, which then passes it over to B, which then passes it over to E. There's a lot of network overhead happening here. Now, obviously, we can save that. We can use a shared volume. We can store the video on a shared volume, but there still might be retrieval to and from the shared volume that offers an overhead. So if I package all those applications into one virtual machine, and I have this scenario where I'm dropping the video and I got the pipeline in that virtual machine that's going to get loaded into memory once, and we're good. Now, that is a valid scenario, but that can be done in a single container. You can have a complex pipeline running in a single container. It doesn't need to be designed to be super microserviced. You can have these microliths that do a certain specific task that may do perhaps many certain specific tasks efficiently in memory on one unit of processing data, right? Think of that video as the processing data that's coming in. Technically, like we said before at the beginning, you can have a full guest operating system as long as it shares the kernel of the host operating system. And while there is some limitation of what kind of operating system is supported, that interoperability between operating systems is growing, is getting better. You've got the Windows subsystem for Linux that, as an example, if you run a Windows host operating system, you can run pretty much any version of Linux that supports WSL. Am I advocating for you to run Windows servers for your Docker just so that you can run WSL supported containerized operating systems? No, not necessarily, but that's an example of how interoperability that can be very easily used by everybody exists out there, and we have that. So do we need virtual machines for security? I'm not going to be an advocate of that anymore. I used to say, yeah, sure, you can bring your security up, you can bring your security posture up at the guest operating system level. You can encrypt the guest operating system, you can run tools for security inside of the guest operating system, but you can do that in a container as well. You can encrypt your volumes in a container. You can pull an encryption key from somewhere else, from external storage, and have ephemeral keys that you can use only once, like your one-time password tokens, for example. No difference. There's no real difference between a container or pod and a VM at this point from the respective security. And then the last argument was, but well, what about legacy applications? What about legacy applications? Well, what's going to happen to legacy applications is, number one, they're not going to stick around forever. And number two, they're probably going to go away at some point or be relegated to maybe some very niche virtualization platforms that are going to still support virtual machines. I believe, my personal belief right now is that Kubernetes is the future of virtual machines. Yes, while you're going to be keeping some, some hypervisors there somewhere in a data center to run your legacy platforms as long as they're required, or maybe you port those legacy applications up into the cloud onto virtual machines in the cloud, probably your best scenario at this point, so that at some point you can just quickly archive them and drop them into the archive tier of the cheapest object storage solution you can find. Your core business is going to run on Kubernetes. Okay, why Kubernetes? Why not OpenShift? Why not just Docker containers? Docker Swarm does things, right? You can do that with Docker. Why not the cloud versions of containerization? Like, why not ECS? Why not the capabilities that exist that cloud vendors have? Well, because what happens in an industry is there is something called industry standards, and your industry standard for virtualization up until this point in the majority of businesses, if you've been in IT for a while, your industry standard is VMware. Why are people not using hypervisors that are not VMware as much? Well, number one, VMware was exceptionally good at the beginning of its sort of first 15 years of its existence. It was exceptionally good. It actually outperformed a lot of hypervisors. I personally was a VMware VCP up until version 5, I think, back in the day. And when we were testing capabilities, when we were testing interoperability, VMware came out on top. It just worked. It was very stable. It was solid. And then also the community that supports that platform is immense. It's huge. You're probably going to find 10 times more people who are familiar with VMware than any other hypervisor. Now, I'm not saying that other hypervisors are not in use. There's tons of Hyper-V. If you have everything running on Windows and if you're connecting your platforms to Azure Cloud, then Hyper-V is probably the best supported, most flexible virtualization platform that you can use, for sure. But it's not the industry standard, right? And when you have other options, sure, they exist out there, but then one thing becomes the industry standard. And this is where I personally believe Kubernetes has probably the best, the lead in becoming the industry standard for the next several decades for how we run applications, how we run applications both on premises and how we run applications in the cloud. And then the question about on-premises or cloud comes up. What's happening with cloud? What's happening? Why is there an exodus from the cloud? There isn't an exodus from the cloud. That number one. Let's dispel that myth. 95% of spend in IT globally, about $5 trillion is spent on IT globally. 95% of that is spent off of cloud. Cloud is a $350 billion dollar business across all the cloud providers. So 90%. Okay, let's say 90% of that spend is off cloud. Even if 90% of that IT spend is off cloud, that means that there is a very, very large majority of on-premises applications. And this is what was confirmed to me with the discussions that I had. A lot of companies are regulated. A lot of businesses are regulated. They run air-gapped systems. If you're running an air-gapped system, you cannot be using cloud because you can't physically access it. You cannot go to the cloud data center and access your application if it's air-gapped, if it's not connected to the network. So those will always stay in data centers. That's number one, air-gapped. Number two, it's not that cloud adoption isn't happening. There's cloud adoption happening, and there's also the evolution of cloud services that's happening. A lot of companies lifted and shifted, figured out, hey, you know what happens when you lift and shift 1,000 virtual machines? Your bill goes up. You're not saving money anymore. Because that was never supposed to be how cloud should be used. You shouldn't be lifting and shifting tens of thousands of virtual machines from your old platform. You should be modernizing. You should be implementing containerization because it's way more efficient, especially on cloud. You're paying in very small units when you run containers, and you can ephemerally spin them up and down. Whereas when you spin up virtual machines, most of those virtual machines in the cloud, they run 24/7, even if they're not doing anything. So a company had 1,000 virtual machines on their local cluster in their local data center, and they pushed them into the cloud, and they kept them running 24/7, just like they did on premises. No change in the evolution of their processes, no change in how their applications run. And virtual machines, again, were not proving to give that benefit back, that flexibility, that scalability that was promised. And bills increased. And a lot of businesses, when they figured that out, they said, oh, you know what? We don't have the technical acumen required to modernize this application. If we're going to run virtual machines in the cloud, it's going to be super inefficient. Let's get off cloud. And they moved the virtual machines back into data centers because that made sense for them. You can only win with cloud when you modernize your application. You can only win with cloud when you use it as an ephemeral resource, a resource where you spin things up when you need them and you shut them down when you don't need them. And regardless whether it's hardware cloud, whether you're running multi-cloud architectures, the way to get that benefit out of cloud is to run Kubernetes, is to run the platform like Kubernetes. Number one, it's positioned, like I said before, it's positioned to be the platform to run applications, because just like VMware was 15 years ago, it's got a huge community that supports Kubernetes itself. It's got a huge, there's a huge drive from the CNCF itself and from all the cloud vendors to support CNCF capabilities in a native manner, in a way where it is interoperable out of the box. It's not a hack between how do I get my VMware virtual machine into the cloud because the cloud supports a different thing that they've built themselves. No, it's all supported. It's all, you take the pod and you just target it to the cloud, you target it to the data center. Why not Docker? Why not Docker Swarm? Why not OpenShift? Why not all of these other capabilities that exist out there? Cloud Foundry, I don't know. Think of your favorite containerization platform. Because of the industry standard, the industry has rallied around Kubernetes as the standard for running containers. It is heavyweight. It's got a heavyweight control plane. It's designed to run at massive scale. And there are scenarios where Docker can be leaner, where the flexibility that OpenShift brings to the table is still better for some businesses. The specifics for developing applications that Cloud Foundry brings to the table, those are still valid points, but they're not going to be massively adopted like Kubernetes is being adopted and will still continue to be adopted. And this is where I think that we have that edge with Kubernetes over all the rest of the containerization platforms. The drive by the community, the adoption, the massive amounts of people who are supporting Kubernetes platforms, and businesses will realize that, hey, this is the enterprise grade, well supported platform where the workforce is growing for it. A lot more people are learning Kubernetes. And I think if you want to future-proof your career, it's not just Linux or just cloud or just Kubernetes. It's all of those together. It's how do I run my containers? How do I develop for those containers? How do I build pipelines for those containers? And then I can run them on Linux, and then I can run them on cloud, and then I can run them on all of those platforms. Sounds like a lot, but that's how I feel about it. All right. That is the lesson that I think I've learned. So what about the legacy applications? Did I answer that question? Well, they're going to stay on virtualization. They're definitely going to stay on virtualization. They're staying on some kind of platform somewhere. They're analogous to how mainframes are today. Mainframes are still there. Mainframes are still there. They haven't gone away. IBM is still building their mainframe platform, still selling it today. You can buy a brand new mainframe if you want to run your applications from the 1970s on mainframes. You can still buy them. Does everybody buy them? No. There was an interesting research done, a recent article that talked about how it actually could be more efficient to run virtual machines on mainframes nowadays, with the lack of hardware, with the lack of capabilities. If you have a certain scale of VMs, the analysis showed that it actually makes sense to go for the mainframe platform. That the Z series can actually support, I think it was something like 700 Linux virtual machines. And then there's the Zephyr AI accelerator that IBM has built for the mainframes, so that you can actually run workloads like large language models on those accelerators, and they're available. You can actually buy them, not like the GPUs that you can't buy. All right, so Kubernetes, containers, this is the way to go. This is what is going to promise, this is going to deliver on the promise of run your application anywhere. Run it on the cloud, run it on any platform, move from one cloud to another, no vendor lock-in, use the same automation, use your, Kubernetes orchestration documents, not some vendor-specific orchestration documents. That's the main idea here. We want to develop our infrastructure as code. So when we're developing our infrastructure as code, we kind of have to decide on a specific language that we're going to use for that orchestration. Is that language going to be cloud specific, or is that language going to be vendor dependent? No. When you're running Kubernetes, all of those orchestration engines, and pick your favorite orchestration engine here. I'm not going to even mention any of them because there are polarizing views between orchestration engines supported on Kubernetes. So pick your favorite Kubernetes orchestration engine, and it runs on any Kubernetes platform, whether it's a vendor-specific Kubernetes platform that integrates some vendor features, like k8s on AWS, for example, or whether it's just plain vanilla Kubernetes, or it's the Kubernetes that's in GCP, which essentially is the same platform itself. It's going to work across all of these platforms. So your disaster recovery becomes much easier. Your migrations become easier. You don't have any vendor lock-in. You're running on open source solutions, which is the best ever. And you get all the benefits of containerization. Yeah, some legacy applications, hey, you're going to have to keep them on VMs for some niche things, and then you're going to get rid of them at some point. Or pack it into a container image. Build a container image from that operating system and squish it onto Kubernetes as a single pod that restarts if it fails. Yeah. There are pathways to achieving that as well that exists. And then one final point I want to make about this whole rant that I'm having here. There is something happening in local compute as well. Edge computing is becoming a really, really important part of computing, because computing is becoming so powerful. Everything that we build nowadays is extremely power dense. And what I saw at the Red Hat Expo was one of the vendors was showing one of their newest generation servers, a 3-unit server, 2 processors in there, a little bit of memory. The 2 processors had 386 cores, physical compute cores, and the next generation is going to have 512, and several terabytes of data. That device there was fitted with 4 terabytes of data. Well, sorry, memory, not data. 4 terabytes of memory. And you can squeeze more, depending on obviously the support of the CPU itself. So we're looking at hundreds of cores and terabytes of memory that are in at each 3 units of your rack. So repurpose your essentially communications rack to have some local compute capability. Every office building has some switches they need, because you got some wires going into desks where computers are plugged in, and there's got to be 3 units in that rack. If it's a 19-inch rack, there's got to be 3 units available to drop one of those servers in. And if you're going to be accelerating your applications with a local copy, I'm not saying run everything on premises. I'm not saying convert all of your network racks into data centers. I'm saying add some capacity to the edge where you can run a copy of your application that runs at local network latency, that runs at sub-millisecond response times. And if you want to do that, then you got to span your architecture from the cloud, from your data center, from everywhere into the edge. When you do that, a platform like Kubernetes is going to have the most benefit. We've already established it's super lightweight, it's super efficient. You don't need to put the 300 core servers in there. You can just put a 1-unit server. A 1-unit server will probably have at least 64, maybe 128 cores in there nowadays. That's the beauty of this capability, this massive increase in how much compute capacity we have available on our local systems, is that we can actually do that promise of just computing is everywhere. Computing sits in every rack and has the capability to support your entire enterprise. And when you have, obviously, that local server fails because something happens, then you have a copy of that application or more pods of that service running inside of your data center, running in the cloud, running somewhere else where they should be. And this is what Kubernetes brings to the table. I'm not saying it can't be done with other platforms. I'm saying the simplest way and the most enterprise ready and the most supported way of doing both cloud computing, data center, hybrid computing, and edge computing is going to be by utilizing Kubernetes as your platform. You're not going to achieve that on your virtualization platforms unless you're vendor locked into one specific vendor. I think that the only real way to be entirely vendor neutral in these scenarios is going to be Kubernetes. All right. This is where I think I'm going to conclude my point. And maybe the end of the VM is the clickbait title that I put on this video, but you can kind of see where I'm going at. And this is coming from anecdotes of individuals that I spoke to, that I talked to at conferences, that say, hey, we're seeing this same thing. We actually want to get rid of VMs. We want to get rid of that overhead. We want to get rid of how we've done things. We want to get to containerization. The path is still long for a lot of businesses. A lot of teams are still looking at that as the long-term future in the next 10 years. But if you want to be, if you want to have a career in computing, you need to be looking at 10 years from now. And 10 years from now, two things are certain. You're going to need to make yourself useful to AI. Think of what you can do for AI, not what AI can do for you. And you're going to need to be able to think in, future, sort of project what's going to be happening in the future. I think that our problem solving, our ability to think outside the box is something that's going to be very difficult to replicate with AI. But yeah, it's still going to be a big part of business. It's still going to be a big part of platforms. So yeah, I'll leave you with that thought. How can you make yourself more useful to AI? All right, everybody. I'm going to check the chat if there's any questions or anything that anybody wants to add. And if there's nothing that's being added, I'm going to say thank you so much for watching this one. I hope you find this style of video a little bit of a break from the norm. I hope you find it interesting. I'm going to also say, hey, before we go, I want to remind everybody that I have started working on the Kubestronaut exam prep tool. So essentially now KCSA is supported. KCS supported. Take a look at this, download it, try it out. I've only have 40 questions right now for the exam style questions. I only have 10 hands-on lab. You can run them on Minikube. You can run them on any proof of concept Kubernetes. Don't run them on your production cluster. Yeah, so those challenges are there. Play around with them. Leave comments. Leave bugs. If you're going to branch out, branch, fork, start this repo. I want to build something really cool. And as I add more questions, as I add more content, I'm going to want to see anybody, whether you are learning Kubernetes or whether you are already a Kubernetes expert, I want to see you tell me what you think about this tool. And I want to make sure that this tool is available to everybody to take, improve, make better. If you're making it better, I'd love to see your contributions be contributed back to the main repo, so we can build something really, really cool. Thank you so much for taking a look at this one. Yeah, here's the link to the GitHub for this one. Thank you. Yeah, the videos are recorded on these same links where you're watching from right now, and I will see you next week, same place, same time. Enjoy, everybody. I'm gonna end this one. Bye.